problems are difficult to solve. Problems include the noise, cost. If you're flying commercial, there's the issues of TSA and screening. But of course, one of the largest issues that aviation faces is pollution, particularly carbon dioxide emissions. The industry has set a target of reaching net zero carbon by 2050. Sadly, we're not going to reach that goal with incremental improvements. If you look at an aircraft from the 1950s, they look nearly identical to aircraft today. And those incremental improvements just aren't enough, and they're not moving fast enough. The industry really needs something very different. There are two options that exist. One is new propulsion systems, and we're seeing a number of companies move into the marketplace and develop new propulsion systems. And we're so excited to see that happen. We look forward to working with a number of those companies on a new geometry, and that geometry is really the second way, and we believe a critical aspect to becoming more efficient. The problem with the battery approach is heavy weight of batteries. Batteries are 52 times less energy dense. In other words, you don't get the energy out of the same amount of weight. So jet fuel is far more energy dense, which allows an aircraft to fly very far and have the energy to carry lots of payload. That's one of the things that we need in aviation that we're not seeing today. If we look at what is happening in ground-based transportation, Tesla and other companies understood that they needed to streamline the automobile in order to reach the range that they desired. Certainly a 57 Chevy and many other automobiles are very classic, but you put batteries in them and you're just not going to get the range you need. The same thing is true with today's aircraft geometries. They're wonderful aircraft, but they're just not efficient enough to provide the range and the payload capability with the batteries and the other propulsion that we have available today. DBT Aero has spent years focusing on how to make the most efficient aircraft, and what we found is that there is a solution. Winglets increase efficiency by about 3%. Our double box tail increases efficiency by more than 30%. That's more than 10 times improvement over winglets. That's the level of efficiency that we need to reach our target of net zero carbon by 2050. Let me give you an example of how this can play out for the industry. If we look at a sailplane, sailplanes have very long, high aspect ratio wings, very small fuselage, and yet they're extremely efficient. They can go a very long ways. If you want to go fast, though, you need short wings, and you need, again, a very small fuselage. If you want to carry a lot of payload, you have a large fuselage, very thick wings. So there's optimizations in today's aircraft. But if you want to go far, fast, and carry a lot of payload, we don't have a solution in the market today. DBT Aero's double box tail is that solution. Provides a combination of range, speed, and payload that is unattainable today. And as I said, with the integration of the propulsion systems that are being developed, everything from battery electric to hydrogen fuel cells, hybrid electric, ammonia, there's many different things that people are looking at. You combine our unique geometry that is highly efficient with these efficient propulsion systems, we will see a new level of aircraft performance and sustainability that we've never seen before. Welcome to the future of aviation. We're excited to be a part of that.